Good morning, all. Now I am going to discuss about milling machines, which is a third unit in machine tools. So the milling machine also comes under traditional machining process. So milling is a name given a machining process in which removal of metal takes place. Due to that maybe cutting action, revolving cutter when the work is fed fast heat. The revolving cutter is held on a spindle. We can call it as a arbor, 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 and the work clamped on the machine table, fed fast the same. So the teeth of cutter is removed, the metal, and the chips, form surface of work to produce that maybe desired shape. So it acquired indispensable positions of the modern productions. Maybe almost all in the cases, maybe just like when you want to generating that maybe slots concerned for that maybe key positioning of that maybe keyholes, and just like general splines cutting, or maybe on the shafts itself. So basically, we are going to use this type of so because of high accuracy and fast production, and just like very long jobs, we can able to just like machining it. So that's why it is a versatile machining tool, right? And what is that general specification, maybe milling specification class, and what are the things that we are going to be discussed in this milling machine? Specification, classification of milling machine, principal features of horizontal, vertical, and universal milling machines, milling operation, types and geometry of milling cutters, and methods of indexing, gear shaping, gear hobbing, machining, time calculations, right? And here, so what is that milling machine? It is a metal cutting operation in which the excess material from the workpiece is removed by rotating the multi-point cutting tool called milling cutter. So earlierly, just we have already discussed about lathe machine, where the workpiece is revolved, the tool is moving, maybe just like along the parallel to the workpiece and perpendicular to the workpiece. That we can call as fed and depth of cut. Okay, but here the tool or milling tool, milling cutter is just like fixed on the spindle. That we can call as arbor, holding part of that maybe tool, that arbor, and the workpiece is kept on that maybe placed on the work table, right? So a milling machine is a machine tool that removes that maybe metal as work is fed against the rotating multi-point cutter. The milling cutter rotates high speed. It removes the metal at a very fast rate with the help of multiple cutting edges. Because so we can call it as a multiple cutting tool here. Because in lathe we can call it as just single point cutting tool. Maybe the cutting edge is single, but here the cutting edges maybe just like multiple cutting edges are there. That's why it's called as a multi-point cutting tool, which is loaded on a spindle. That spindle is called as a arbor, tool holding part. Okay. So one or more number of cutters can be mounted and simultaneously for maybe suppose when you want just like a flat surface is there, when you want to just like generate in the parallel two or three slots. So in this case, this is a reason that milling machine finds that wide application in the production work. Used for machining flat surfaces, contoured surfaces, external and internal threads. So that also we can able to obtain by the milling machine, right? So as the workpiece is moves against the cutting edges, milling cutter, metal is removed in form of chips. So machine surface formed in one or more passes of that. Maybe it is not one pass is not possible, just like finishing the final product. So maybe two or three, four passes may be just required based on the depth of cut that you have given. Okay, and the work to be machined is held in a vise, rotary table, and a three-jar check indexing head in a special fixture of the bolted machine table. So in many applications, due to that maybe higher production rate, accuracy milling machines are evenly replaced with that maybe shapers and slaughters, right? So the shapes which we can able to obtain by milling machines, so plain surfaces or maybe integrated surfaces or V shapes or maybe stepped cuttings, whatever the slots that we can able to just like we can able to easily generating by using milling operations. These are that maybe just simple components which we can able to produce by milling tools, a milling machine, right? And what are the milling methods that we are going to use that? So two basic methods of millings that we are using. One is that up milling or conventional milling, and the second one is the down milling or climb milling. Down milling or climb milling. Right, that up milling or conventional milling is, so in metal is removed by cutter rotating against the direction of the travel of the workpiece. So if that workpiece travel is same as that of that metal cutting, that is not maybe up cutting, maybe just down cutting. If it is maybe up cutting means, so the tool which is rotating against the travel of that maybe workpiece need a stronger holding of the job. Chip thickness is minimum at the start of cut and maximum at the end of cut. So as you know that maybe some disadvantage, so tendency to lift that maybe work from the fixtures and poor surface finish may be applied. So right, and here this is the diagram, conventional diagram, that we have a conventional milling method, conventional milling method. So that we can call as a up milling method. So as you know that the arrow which is shows that maybe opposite the direction, and the tool is rotating clockwise direction, rotatable direction, and that maybe here the workpiece is rotated opposite to that maybe tool rotations. So that's why it's called as maybe just like conventional milling or up milling process, right? And what about the down milling process? Second one, down milling or climbing milling process. Metal is removed by cutter is rotating in the same direction of the workpiece. Both cutter and as well as workpiece are in the same direction. So teeth cut downward instead of maybe upwards. Teeth cuts are maybe downward instead of upwards. So chip thickness is maximum at the starting point and minimum at the ending point. Less friction is involved because there is not much strength is required, and better surface finish. So less power consumption also there because both are in the same direction, right? And the conventional diagram for the these that maybe both are same. This is the climb, down or climb, down or climb. So which are in the same both direction, so same direction. As you know that maybe earlier case, up or conventional milling process, conventional milling process. So this is the down or climb milling process. Both you can observe that both cutter and as well as maybe workpiece is in the same direction that you can, the arrow marks which indicated with the green arrows that we can indicate it that same direction. Okay, the tool which is having a multiple cutting edges, that's why it is called as a multiple cutting tool. Okay, so the chip thickness at the earliest stages is the maximum, and later stage it may be just end of that maybe cutting it will be minimum, right? And the principle of milling cutters. So as you know that, so workpiece fed against that milling cutter, and workpiece fed with a milling cutter. That is conventional milling, and other one is the climb milling process. So here, and the classification, there is a broad classification is maybe up milling and down milling, and the general classification of column and knee type of milling. We have so many broad classifications of milling machine that we are going to consider knee, column and knee. So one is that maybe hand milling machine, horizontal milling machine, vertical milling machine, universal milling machine, right? So hand milling machine, horizontal milling machine, vertical milling machine, and universal milling machine. Based on that, maybe a column and knee positioning, so that we are going to classify it. Okay, and the first one is horizontal milling machine. So how it is working? The horizontal milling machine has a spindle that is parallel to the shop floor, and an overarm that exceeds over the workpiece. The overarm supports that arbor, so which holds the milling cutter. On the maybe in horizontal milling, the arbor is component that rotates the milling cutter, because the milling cutter is fixed on that arbor. Milling cutter is fixed on the arbor. Okay, so the arbor is just like spindle, it rotates continuously, but the workpiece is maybe keep on that table. Okay, this is a schematic diagram you can able to identify it. So this is the diagram, you can just like front view and side view of that horizontal milling cutter. So the setup is here, you can just like see that there is a overarm, and there is a arbor bracket is there. This spindle is nothing but called as a arbor, so which is holding the tool different positions. That tool means milling tool, it can be just like holding it and after that, that milling tool we can call as a cutting tool, as you know that. And machining vise is there. So machining, which is vise which is fixed at the on the table itself, and the vise is used for particularly just like holding the workpiece different positions. And after that we have a cross transverse handle that they're just giving that maybe different movements to the table. And we have that arrangement, and there is a knee that we have, and vertical traverse. There is we can be able to lift the table upward direction or downward direction. And this is the bottom, maybe just like we can call it as just like base, the base that we can call it as that which can support in the machine. So this is the horizontal milling machine that we can able to identify the front view and side view for this one, right? Okay. The tool is always rotating. The workpiece is fixed on that particular table. Okay. The horizontal milling machine, the cutting tool is positioned horizontally, parallel to the work table. So cutting tool is just like positioned horizontally parallel to the work table. Okay. The main spindle axis of that machine always called as a jed. You see the spindle axis is nothing but called as jed, and mounted the movement of the table on x-axis and y-axis that you can indicate with that x-axis and y-axis in the direction, right?